Okay, so the second problem that we had planned for this morning was page 298, question 39. Sorry, it's not question 2, question 39. And this problem is also with the continuous uniform distribution. So the context that you have here is you have a business executive who has been transferred from Chicago to Atlanta, and she needs to sell her house. The employer has offered to buy the house for 210. So her employer is offering $210K, $210,000 for the house, but the offer expires at the end of the week, and the executive doesn't have any other competing offers in hand, but she knows that she can afford to leave the house on the market for another month. And if she leaves the house on the market for another month, her agent or somebody else in the real estate market, somebody tells her, somehow she knows that if she leaves her house on the market for another month, she can get a price between 200,000 and 225,000 uniformly distributed. Okay, so there is a chance that she might get more than what the employer has offered. Okay, so that's the setting of the house, and she's trying to make a decision on whether or not she should leave the house on the market for a month or take the employer's offer of 210K. So that's the context. So part A of the problem says, what is the mathematical expression for the probability density function of the sales price? So essentially they want to know what is the shape of the probability function for the sales if she leaves the house on the market for a month, and the narrative tells us that it's uniformly distributed. So if you had to draw the probability function as a picture, this is the picture that you would draw. Okay, and to complete the picture, I would have to identify what the height of the uniform distribution is, and that would be 225 minus 200, or in other words 1 divided by 25. That would be the height of the probability density function, because the area of the whole curve is 1. We know that from the laws of probability. The area under the density function has to be 1. So base multiplied by height is equal to 1. Hence the height must be equal to 1 divided by the base, which is 1 divided by 25. So the part A says, instead of drawing this picture, if you had to write this as a mathematical expression, how would you write it? So you write it in 3 pieces, okay, because it's a uniform distribution. Parts of it are 0 and part of it has a certain height. So you would say that the density function, in other words, the height of the function, is equal to 1 divided by 25 as long as x, that is the offer that the lady gets on the house, the executive gets on the house, is between 200 So in this range, when x is between 200 and 225,000, the height of the curve is 1 divided by 25. Okay. Anywhere else, the curve is 0. Okay. So if x is less than 200, then of course it's 0. That's this portion here. And the height of the curve is also 0 if x is greater than 225, isn't it? That's pretty obvious from just the shape of the curve. So anywhere x is greater than 225, the height is 0. It's only when x is between 200 and 225 that the height of the curve is 1 divided by 25. So this is the answer to part A. Now part B says, if she leaves it on the market for another month, what is the probability that she will get at least $215,000? So again, if you draw the picture, we know that there is a uniform probability from 200 to 225. Okay, so let's say this is 215. Okay, so the problem says, this part says, what is the likelihood that she gets more than $215,000, which means I want to know the area that I just shaded. Okay, since it's a rectangle, it's equal to base multiplied by the height. The base is 225 minus 215, and the height, of course, is 1 divided by 25. These are all in thousands of dollars. Okay, so I just not writing the last three zeros, and the height we have already computed from. This is where we got the height from, right? So this is equal to 10 divided by 25. So there's a 40% chance that she will get more than excuse me, $215,000 in the market. Okay, and then part C, let me go to a fresh page. So there's a uniform likelihood that she will get between 200 and 225. Part C says, what is the likelihood that the offer she gets, X, is less than 210,000? Remember, 210,000 is what the company is offering her. Her company is offering her to buy the house immediately or within a week for $210,000. So, sorry, it says the question, part C says, what is the likelihood that if she leaves her house on the market, that she actually gets less than what the company is offering her right now? Okay, so let's say this is 210. So I want to know the likelihood of X less than 210, which is the shaded area on the left. This is equal to base multiplied by the height. You remember the height was 1 divided by 25 from the previous parts of the problem. So this is equal to 10 divided by 25 is 40%. Okay, so should the executive leave the house on the market for another month? So should the executive leave the house on the market for another month? So notice that if she leaves it on the market for another month, there's a 40% chance that she will get less than what the company is offering her. So it's a close call, and if you look at the previous parts of the problem that we did, part B says the likelihood that she will get higher than what the market is, what the company is offering her, 215,000 is 0.4. But there is still a fairly good chance that she will get an offer that is less than the market. So there's a 40% chance that the offer that she will get is less than what the company is offering her. Okay, still, since the chances of her getting a higher price is just slightly higher than, a little bit higher than 0.4, it makes sense to leave it on the market for another month. But it's somewhat of a close call, you can see, because if this likelihood, this point, the likelihood of getting less than 210,000 was, let's say, 0.3 or 0.2, then you feel much more comfortable. Hey, there's a much higher chance that I will get an offer that's more than what the company has offered, but these numbers seem to suggest that it's a close call. Okay, so the answer is yes, the executive should leave the house on the market for another month, but it's a close decision.